Think forward. Think Research Channel.
From the National Science Foundation, where discoveries begin. This is Frontier. Discussions of today's most exciting research subjects by distinguished scientists and engineers working at the frontiers of knowledge.
I'd like to welcome you all to the celebration of the International Polar Year 2007-2008, hosted by the National Academy of Sciences and the National Science Foundation.
The last speaker is Stephanie Pfirman, who's a professor and chair of Barnard College, Columbia University, Department of Environmental Science. And she's engaged in research on surging Arctic glaciers, dynamics of sea ice, and Arctic sediment and contaminant transport by sea ice. And Stephanie's going to talk about the Arctic and a range of IPYs from the first to the future.
So many people have spoken about the connections that IPY is making with the general public and how scientific research is being integrated into many different forms of communication. And what I'd like to do today is to showcase some of those, some things that we've done in the classroom, in museum settings, and also in terms of actually a traveling roadshow, which is where we'll start. I'll be showing a short clip from Polar Palooza, which is a traveling roadshow of polar science that has been going around the country here, has given presentations in 24 communities across this country and is going international next year. And what we'll do is we'll hear from Richard Glenn, who will introduce himself, and this will also help to give you a voice directly from the north, and so you'll be able to experience this as the public does.
My name is Richard Glenn. I live in Barrow, Alaska. I'm the president of the board of directors for the Barrow Arctic Science Consortium, and I work for Arctic Slope Regional Corporation as the vice president of lands. So my job is to manage our lands and to advocate for good resource development that happens on our terms, and to balance that message with our values, our own values of respect for the land and the resources they provide.
Forecast for the northern Arctic coast for tonight, mostly cloudy with areas of fog, high temperature 40 to 45.
We know that it's getting warmer, that even for those of us who live at the northern edge of the Arctic in the United States, we see that freeze-up happens a little bit later every year, breakup comes a little bit earlier, and this has been going on now for several generations, so that our elders remember times when it was both colder and when the winter season was longer. That changes how you watch the calendar, but it doesn't change how you behave in the environment. And so sons are learning from fathers and grandfathers and uncles about how to monitor changes in the seasons, changes in the environment over time. There's no single library. The libraries are in the minds and memories of our elders. And maybe they're learning too from somebody older than them. It's uninterrupted through the generations. I think the world is occupied their mind with global warming and the changes in the environment. But our culture is kind of built on change, so we're not, I don't think, threatened by it. We're not the canaries in the coal mine, but we're people who are aware of their environment and its changes and are adjusting with it, just like we've adjusted to every other kind of change. And we have to roll with it. We just got to roll with the punches, like it's probably happening everywhere else. It affects life in many ways here. And so, yeah, they talk about it. They talk about it because if we have to travel farther to get our food, be more vulnerable to storms, or if the seasons change, affect our travel or our access to our places, then it becomes very real. And it's more than just dinner table talk. It's what puts food on the table. Food on the table.
So I think you can see that he covered many of the same topics that Hayo covered, actually, in his presentation, but in a different way. And some audiences will respond more to this type of message and this type of delivery than the charts and graphs that many of us are used to as scientists. And I think that that's really an important finding, and it's something that we've deliberately tried to do throughout this International Polar Year to a much greater extent than had happened in previous polar years. And I just want to echo back to what Dr. Pfirman said at the very beginning, that it's really extraordinary to me as somebody who's worked with polar historical exploration to be standing here today on April 6th, 2009, exactly 100 years after the potential attainment, or at least getting close to the North Pole back 100 years ago. So what I'd like to do now is I'll take a look back first before we take a look forward. And Carl Weiprecht has been called the father of the International Polar Years. One of the critical theories or approaches that he had was to distribute the collecting system, to create a distributed set of field camps that would help us to collect the data that are necessary to understand the global processes. And Tim Killeen talked about the Earth system science perspective that is so important to us today, and he really set the stage for this when the stations were put together back in 1882. These stations were distributed around the Arctic, and many countries participated. What I'd like to do now, though, is actually to do something different, which is during the time of this international collaborative effort, there was also something else going on, and this was a failed expedition. It was the Jeannette. The Jeannette was trying to reach the North Pole, coming up through Bering Strait, and they had started earlier than the International Polar Year, and unfortunately the ship was crushed in 1881. But what happened was that in 1884, the wreckage from the Jeannette was found along the southern coast of Greenland, and this led Fridtjof Nansen, one of the most important polar explorers, to think about the route. And what he thought was, if the wreckage is crushed north of Siberia and winds up along the Greenland coast, then it must have passed over the North Pole, or at least close. And so he used this knowledge of Earth system science to put together his own expedition where he deliberately froze his ship in. And he traveled along the coast of Siberia. Here, he took the ship from Norway, traveled along the coast of Siberia, up along here to the New Siberian Islands, and then deliberately froze in his specially constructed ship, the Fram, here, and the ship drifted with the ice, almost as planned, through the Arctic. This is the North Pole right here, and emerged between Greenland and Svalbard 3 years later. Now, he had provisioned the ship for 5 years. He knew from the Jeannette wreckage that it might take something like 3 years, but he was very cautious and an excellent planner, and he actually provisioned the ship for 2 more years. What happened was he actually did leave the ship when he realized it wasn't going to attain the pole. He tried to ski to the North Pole, then realized he wasn't going to make it, turned around, came back to Franz Josef Land, met up with Jackson, an English explorer. It was one of these amazing situations that you just think can't happen, but they actually did. Happened to meet on Franz Josef Land. They didn't prearrange this at all. And then Jackson was able to bring him back to Norway. When Nansen arrived in Norway, Fram had not yet emerged, and so he was a little concerned, but exactly 1 week later, the Fram emerged. And so they were able to join together, and here you can see the massive crowds that turned out to welcome Fridtjof Nansen and the Fram home. Now, what was interesting about this is that, being a polar scientist myself and being at Barnard College, I wanted to try to bring the excitement of polar exploration to my undergraduates at Barnard. And they're all women, and they're all very urban associated. That's why they come to New York City to study. And I thought, how can I do this? And I thought, well, maybe if I actually put them in the shoes or in the ship of Nansen and let them explore themselves. So we put them in teams. And we have them start where Nansen started, and then we look to see where the expeditions might travel to if they were to travel in different years. And this is using the actual ice conditions. So the students don't know where they're going to wind up. And they're competitive in terms of being teams. And what we found in doing this analysis is really interesting, is that Nansen would have gotten to the pole, or much closer to the pole, in almost any other year. The natural variability is such that his route was actually fairly far to the south. But all these other purple tracks are the tracks of the student expeditions that would start in '79 through 2003 when we have data, and they all got closer to the pole than Nansen did. So this taught the students something about variability. But what was also interesting was the duration of the drift. And this is something that Hayo mentioned earlier. The duration of the drift is usually, it took, through '79 to 2003, it would have taken, the expeditions would have taken about 3 years. And the Fram drifted for 2.9 years, but many years it would have taken more. Now, as I said, Nansen had provisioned the ship, and so he would have been okay. But what's interesting is that his drift rate was sort of at the low end, and so that was fortunate for him. Now we fast forward 100 years later until just a couple years ago, when the Tara expedition, under the leadership of the Damocles group and Jean-Claude Guescard and the French, they actually tried to reconstruct or redo this expedition by freezing a ship in, where Nansen did, and then seeing what happens. And what's neat is that the route actually that they take is actually very similar to the ones that the student profiles went. They come much closer to the pole, but what's really extraordinary is this. They take 1.2 years to go from the initial point to Fram Strait, whereas the Fram expedition took 3 years. So as the ice is shrinking, as we're changing from multi-year ice to first-year ice, the ice cover is becoming much more dynamic. And so the processes that are governing the circulation of the Arctic ice are changing dramatically. Now, this is the image that Hayo showed here, and what we can do now is we can say, okay, this is what the conditions are right now. What might it be like in 50 years, and what implications do those have for us? So if we take a look at some modeling results, what they show, actually not surprisingly, is that maybe in 2040 or 2050, you might have a very similar sea ice distribution pattern as this, except it would have shrunk. But it would be located pretty much in the same area. So basically it's the winds that are pushing the ice up against and piling it up against the northern Greenland and northern Canadian shelf here. And this is likely to be a place that will have sea ice for much longer than any other place in the Arctic. So you see these graphs and you see the Arctic ice diminishing and you think that it might be shrinking equally. But it's likely that this area will maintain ice for much longer than any place else, and potentially in the summer, and potentially it could maintain the ice for decades longer. So what are the implications of this as we look ahead? Well, one of the things is, as Hayo had mentioned, the sea ice is a platform for the ice-associated habitat to feed, to breed, for transportation. And so many ice-associated species are going to collect in this area, which may become the last sea ice refuge in the Arctic. And one of the most charismatic of these, and at the top of the food chain, is the polar bear. And the polar bears have really captured the public attention. I'm sure all of you have talked with people and you talk about the Arctic or you talk about ice melting and people say, what's going to happen to the polar bears? And I think this is something that we should be aware of, is that the public is really concerned, even though we don't see polar bears day to day, at least most of us don't. The polar bears are this iconic image, and people are very concerned about preservation of these, what they consider to be often the remote environments that should be pristine. This analysis here that just came out in February shows that over much of the Arctic, in fact, almost all of it, the projection is that by about 2050, the middle of the century, the polar bear habitat will shrink. But in this one area right here, where we expect to see sustained ice coverage, the polar bear habitat will be maintained. Now, what does this mean in terms of ice drift? So if we think back to Nansen, the ice is not static. So you don't have an ice cover, like an ice sheet that melts on the sides and then extends again. You have this very dynamic cover. So if you want to maintain the viability of this ice habitat here, what you actually need to think about is the ice shed that's feeding ice into this region. So what we did was we took data that had been obtained from buoys that were deployed on the surfaces of the ice and then tracked with satellites. And we colored the coastline as if we put dyes around the coast. And we looked to see where the ice would travel to get a feeling for what would be what are the potential sources of ice to this and other regions in the Arctic. And up here you can see the image that basically recreates the Nansen Drift here in the brick red. Nansen started here as well as the Tara, and then the drift was here and the North Pole is here. So I'll start the animation and you'll be able to see in gray is all of the ice that's older than 1979. And what you can see is, again, this is the sort of the approximation of the Nansen Drift, but look at this. The dark blue ice is coming from the Chukchi and it's coming around here. Or from the Beaufort Sea and coming around. The dark green is Greenland ice. The teal color is Canadian ice. And what you'll see by the end of this animation that just goes until 1997 is that the ice sources in this region are a mix of locally formed ice plus ice that's advected in from other regions. So what we're wondering now, and what we're working on actually, is how will this change in the future? What will be the contributions from the exclusive economic zones of other countries as they develop, as Hayo was talking about? How will those changes and potential contamination of any ice there, how might that get advected into this region and affect the habitat, the last sea ice refuge? The opening of the Arctic Ocean is another aspect of this. I've been focusing on the ice so far, but as the Arctic Ocean is opening, you can see that there's been a lot of interest, and I'm sure all of you are aware of this, of how we're going to manage the shipping and the traffic there. And again, it's really interesting that here we are 100 years later, and again, flags are being planted at the North Pole, in this case by the Russians at the Lomonosov Ridge. This melting of the Arctic ice, as I mentioned before, and the plight of the polar bears has captured the public attention. Many surveys have been done of this, and this is just one I'll show you here, where the investigator asks the public, what is the image that comes to mind most when you hear the word global warming? And melting ice comes out as number one. Heat and nature, ozone, even flooding and sea level rise, referring back to Dave Holland's talk, is lower on the list. But melting ice is the most salient issue. And this is in part because of the changes, and largely because of the changes that are actually happening. But it's also in part because of the deliberate efforts that have been supported under the International Polar Year. These slides, or these images, were given to me by Dave Carlson at the International Program Office. And he has been really struck by the reach of the International Polar Year, way beyond what we had thought it might, where we had thought it might go. Here you see a map, and this is just 200 responses to one of his programs, which was launching a virtual balloon. And this is not all of them. This is just the 200 most recent launches. They did 8 polar days during International Polar Year, and each one of them had a huge response and a very international response. Here you can see Chinese students in an after-school class where they're also working on a polar activity. So the reach of the International Polar Year has been global, and it's gone into all these different levels, into school children, activities for school children, as well as for the general public. And that's what I'd like to show here, is one that I've been involved with. The International Polar Weekend that we've been holding up at the American Museum of Natural History for the past 3 years has attracted more than 10,000 visitors. The visitors are engaged with scientists who have actually been in the field. And one of the modifications we made actually is, the first time we ran this, we would be showing our activity and we'd be talking to the public, and then at some point they would say, were you actually there? And we said, yeah, we were there. And so they would say, wow, that's really neat. So what we did after that was we always included a picture of us in the field, and we started talking to the kids that came, and we would say, look, if you become a polar scientist, then you can go out in the field and you can do this kind of work someday. What you can see here is that we have a range of the public that's interested in this, and they're incredibly engaged. When we surveyed them about why what their interest was in polar issues and in climate change before they came to the museum, we were really struck by the fact that 67% of them said that they were interested or extremely interested even before they came to our polar weekend. So there is a public out there that's very receptive to the messages that we are promoting to them. And the other thing that they said is that they really appreciated the fact that we took the time as scientists to come there in person and talk to them and to answer their questions. They said that they couldn't get this information anywhere else, and this type of delivery and this type of interaction is something that they really valued. The other aspect of this is that we could bring these scientists in because they were supported for their research by the International Polar Year funding. So they were research scientists that were brought into, they were funded primarily to do research, but there was an education outreach component to their support. And because of that, they were really looking for public venues. So I think this model where you fund the research, but you have a very deliberate education and outreach program is something that could become a model for future scientific endeavors in the future and as we go on. So just to conclude, as we look ahead to the IPY of 2050, as others have said, this is a critical time of transition, and I really want to speak to you as policymakers and as decision makers, because you're on the front lines of this, and you're in the position right now to make the decisions that are really going to help us see how we head towards this next period, this new regime in the Arctic. You have an engaged scientific community, you have a concerned public, and what we're really looking for now and what we need is a monitoring program, a sustained Arctic observing network. We need the projection capacity that Hayo Aiken talked about, but we also need a management strategy that deals with both the adaptation and the mitigation aspects of climate change. Thank you.
I'd like to invite the speakers now to come up to the podium. And if we have questions from the audience, we have some time. Yes, there are microphones on either side of the aisle. Yes.
Yes. I'm Annie Quilmot from the IPY Merge project, and I have a question for Diana. Dear Diana, would you consider that microorganisms, and more particularly bacteria, that are the basis of food chains in the continental Antarctica, are also likely to be impacted by climate change?
Evidence elsewhere is showing, I don't know about the evidence for within continental Antarctica, but evidence elsewhere is showing that there are changes in bacterial composition in soils. I don't know of the data, and in fact, there are just now people looking, particularly in the dry valleys, at the sequencing for the bacteria.
Yes.
I am Sverker Sörlin. I'm chairing the Swedish IPY committee, and I'm also a historian of polar science. I would like to ask this distinguished panel, what is the current orthodoxy when it comes to the previous time when there was an ice-free summer Arctic?
Sorry, I actually didn't quite. Can you?
When was there last in history, back in time, an ice-free Arctic in the summer? Is there a current orthodoxy on that question? I see a number of propositions about this. 3 years ago, there was a NASA scientist saying it was millions of years ago. I've heard others express other opinion on that.
Well, I'll get back up from Richard on this probably, but I mean, there's a number of, as you're well aware, there's this really seminal study that was published in 2006 that's a result of this ICEX drilling in several spots that really has transformed our thinking of the sea ice cover in the Arctic. Prior to that, I would argue the consensus was that, well, you know, we've had sea ice in the Arctic for maybe 5 million years at the most, maybe only 2, and that then at that point we basically went very quickly to a perennial ice cover. Now what the ICEX cores have shown us, you know, to reinforce what Richard said, was that, well, actually we went in a very rapid transition during the Pliocene, you know, roughly what, 50 million years ago or so, from a completely ice-free ocean where even though the North Pole was very close to where it is now, where we had surface water temperatures as high as 20 centigrade during the summer, you know, an Arctic Ocean that was very much more like a sort of a tepid subtropical lagoon, we went to something that had seasonal ice cover, you know, and from what I can tell, that evidence is fairly good over a matter of a few million years, and then clearly about 13, 15 million years ago, we probably entered into the current regime. And what's interesting about that is, and I'd be interested to hear what Richard has to say about this, but you know, I always thought about sort of the Antarctic as the region of stability. You know, there was the 40 million year time frame where, well, that's when things settled down. We had the seasonal ice cover ever since, and the Arctic kind of was trailing back there, and it did its own thing. But now I think we're much more in this mode where we're starting to see, well, actually the Arctic may have been driving a lot of this, and so that's why we need to pay close attention to what's happening in the Arctic relative to the Antarctic.
Yeah, I would agree with Io that indeed the onset of sea ice in the Arctic, the onset of ice in the Arctic parallels the drop in CO2, and it more or less parallels the cooling in the Antarctic. But summer is hard, and I think it would be fair to say that there is not an orthodoxy about when the last time was that we had an ice-free summer in the Arctic. And it's just plain hard. When there's no ice, there's very few large rocks get carried out in the middle of the Arctic Ocean and dumped. And when ice shows up, even sea ice, it manages to pick up a few large rocks or at least sand from near the shore and take them out in the middle of the ocean and dump them. So it's very easy to say ice, no ice. It is very much harder to say, was there a week in late summer when the ice was off? And for the whole Arctic, we don't really have the resolution of the records to say that.
Next.
Neil Hamilton from WWF. It's not often that a group of scientists like you get to talk to a group of policymakers like the group that's assembled in this room. So my question to you is, beyond the clear and obvious need for more monitoring and more observation, what would be your policy recommendations to the people in this room?
Have fun.
Let me start on that, and then I will shut up real quick. Once the scientific community, through its assessment, through the assessment mechanisms that have been built for us, the National Academy of Sciences of the U.S., National Academy of Sciences of other countries, features such as the IPCC or the CCSP. Once the scientists have been called before the world by the assessment agencies and asked to provide guidance on what we know, what's solid, what's silly, and what's speculative, once that guidance has been provided, the science is actually pretty good, and you may take it and work with it, and you probably know better what that science means than you know is the basis for policy in almost anything else you do, because it has been run through these assessment agencies. And so what the National Academy does for you here, what the IPCC does for you, is say, this really is the science. It is not something that then is debated in the press. It is not something that you go and say, oh, but are those people lying to us? It is the science, and it forms a basis for your policy-making decisions that is very solid, and it is probably more solid than the basis you have for anything else that you try to do. What you do with that as a policymaker is then say, that's what we know. How does that fit into the real world of what we do, how we humans interact with it? Do we mitigate? Do we adapt? You make the decision, but the science is good, and that's what this institution, that's what the IPCC, the CCSP, the various other institutions do, is the voice that comes out of these is not one more voice. It is the voice of science.
Stephanie?
In terms of managing the transition that's coming ahead towards an ice-free summer Arctic, I would encourage you all to remember that the Arctic is a system and that it's interlinked. I showed it in terms of ice. It's the same in terms of water and also in terms of the atmospheric, the air shed. So what happens in one part of the Arctic gets transmitted to another part of the Arctic. And so I would encourage you not to think of developing your own areas in isolation, but to consider what the connections are with the rest of the system.
What do you mean?
Go ahead.
Yeah, to the gentleman who was asking the question about policy, I think policies of the future have to be scientifically based. So it's the role and responsibility of the scientific community to provide the knowledge base on which sound policies can be made. I don't think one can expect scientists to recommend policies in the linear way that you suggested it. I think there needs to be a handshake, there needs to be iteration, there need to be options, analyses, assessments done, and the science needs to be flexible enough to look at the ramifications of particular policy pathways, and the policymakers need to have the trust and confidence that what they're hearing from the scientific community is credible. And I think if you were listening carefully, you might have heard a policy recommendation at the end of Stephanie's talk, actually.
Dan?
Yeah, I would just say that I in agreement with everything that's been said here, and my only tidbit that I would add is that when we're thinking about ecosystem management, we no longer are thinking about just the biotic component. We're thinking about the physical and the many changes that are occurring both in the Arctic and the Antarctic. And these are interrelated, and we can no longer just kind of put biodiversity and ecosystem functioning off to one side without considering all the interactions and the feedback that it's having with ice or lack of ice and changes in the climate.
If I can add to that, I mean, but one of the challenges, though, and maybe that's something that the group of people that's assembled here can help with, is that polar research is very much international. Collaboration between indigenous people in the Arctic is very much international. You look at some of the co-management commissions, for instance, for walrus, that actually hand off some of the management of a protected resource to the people who live there, who use that resource, and who've demonstrated both in Russia and the US that they can manage this resource well. All of these things very much rely on international collaboration. And one of the concerns, of course, is that as we're moving into a different Arctic where people start to reassess their position, you know, and you could look towards, say, the Ilulissat Declaration last year or some other signs, that it's important to try and strike a good balance between the large-scale policy or geopolitics, if you will, and building on the existing international frameworks and international networks at the local level, at the scientific level, that are going to help us ultimately keep track and prepare for this different Arctic. That's a key point. And arguably there's not enough discussion of that. And certainly the group here can very much help with these issues.
Okay. Any other questions? Yes, David.
I thought I'd ask this as a stimulative question. There's this transition going on in the Arctic to perhaps a state that looks like the Antarctic sea ice zone. And nobody's really answered the question of how quickly could this happen. Now, if you take Richard's view that maybe the climate models are a little bit conservative, then we could be approaching very rapidly a tipping point. So I'd ask for comments on when is the Arctic going to be ice-free in the summer?
Well, I'm going to I'm going to tell you that I'm not going to answer your question, and I do that with conviction and pride, I guess. But I mean, first of all, this notion of a tipping point is something that is interesting and can engage the public, but you have to be very, very careful, I would argue, about how you think about a tipping point from a physical perspective and also from different disciplinary perspective. If you listen carefully to what say Richard Glenn was saying in that video, or if you go out and talk to people in Alaska coastal villages or in Greenland, I mean, their tipping point, if whatever you want to call it, was 2 decades ago. And if you ask people, well, how do you adapt? There's an interesting study by Sherry Gearhart and others with a quote in there that struck me, where it was sort of, to paraphrase it, well, we don't adapt, we just do things differently. And people do it immediately, and for them, observation and response are one thing. And so to take that, I think you would argue that already a lot of things have changed in the Arctic as a result of changes in sea ice cover. But at the same time, I would also be very cautious in regards to saying that, yes, we're seeing that transition to possibly a seasonally ice-free Arctic by the middle of the century, but at the same time, as we've seen in the Antarctic, even with very high ocean heat fluxes, at low latitudes, lots of solar heat input, if a modeler thinks about an Arctic ice-free ocean, it's a very different thing from what a paleoclimatologist thinks about. It's a very different thing from what somebody working for industry who's starting development is thinking about. It's a very different thing for somebody who's living in a coastal community is thinking about. And that is something that I think we, both within the scientific community, can help, because of course we may know about all these different things and how they're going to evolve, but we're not necessarily good at thinking in these different categories. But we're sending the wrong message if we're all lumping this together and saying, yep, the ice-free Arctic is going to come by 2037, without qualifying it, saying, well, here's what this means. That's really where the the icebreaker hits the ice.
Let me just, we have to wrap this up, so let me leave you with a thought. This International Polar Year comes at a fundamental time in human history. All previous generations on this planet saw the Earth in some way as infinite, whether that was infinite in terms of there's more land to explore, there's more ocean to explore, or whether it was infinite in terms of the ability of the atmosphere, water systems to absorb the carbon dioxide, the sulfur oxides, the waste that we put into the atmosphere. But every generation prior to this one saw the Earth in some way as fundamentally infinite. Every generation from now on will see the Earth in a fundamentally different way. We, and every generation from now on, will see the Earth as finite. We know there are limits. We know we can change climate. We know that through our actions, ice melts, sea level rise, climate change, all of these things we have impact on. I'd like to close this by thanking our speakers. Thank you very much for showing up. Thanks very much for your talks. On behalf of the Polar Research Board, I'd like to thank the National Academy of Sciences for hosting us. And I'd also like to thank, in particular, Carl Erb and David Bromwich for their excellent efforts at putting this afternoon together. And finally, I'd like to thank Chris Elfring and Martha McConnell, who work with the Academy here, for putting together what I think was a very stimulating and hopefully for all of you a very enjoyable afternoon. Thank you for showing up. Thank you for attending.
Think Forward. Think Research Channel.